Hooray.
All right. Now, what we're going to do here is let's take...
Can you move it up?
Yeah, I can. Thank you. Problem number 11 on page 465. I know you don't have your book with you, but I want us to talk about this. And we looked at it real quick yesterday. We talked about y equals the square root of x. And we did this, and we said we were going from 0, let's just say this was 0 to 3. I don't remember what we did yesterday. But if we were going from 0 to 3, and we were rotating it, then that was the integral from 0 to 3 of the square root of x squared dx, and then of course pi being multiplied by it. Do y'all remember setting that up yesterday?
Yes.
All right. What I want to do a little bit different today is I want us to consider this same graph. But this time, instead of rotating the graph about the x-axis, I want to rotate this graph around the line y equals -1. Okay? Now, got a few things to consider here. The first thing is that when we take this region and we rotate it about this line, which is the x-axis, when we rotate it about the x-axis, it's going to have a certain volume. When we rotate it about this line, even with this hollow part in here, you're still going to have a volume, but it's going to be actually a little bit larger than if you were just rotating it around the x-axis.
Is y equals -1 the center of the...
Yeah, after you rotate it, there'll be the hollow part there, and in the center of the hollow part is going to be y equals -1. Is that good? All right. So, we're still going to consider this as the area of the outer circle minus the area of the inner circle. Okay? It's going to be the area of the outer circle minus the area of the inner circle. And the area of the outer circle will be a pi r squared, and the area of the inner circle will also be a pi r squared. Now, what would be my radius for my outer circle? And understand that it will look like this. Because if I'm not hollowing out the inside, then I would have a solid that would look like that. It would be. The radius would be the square root of x plus an additional 1. So I'll have pi times the integral from 0 to 3 of 1, looks a lot like a plus, 1 plus the square root of x squared. Dx, thank you. Now, the inner circle that I'm hollowing out would be what? Just 1, yeah. And its radius would be 1 everywhere. Its radius would be 1 here, it'd be 1 here. It's 1 everywhere, so it would be the integral of a constant. Minus it, thank you, not times. Are we good here? All right. So, it's going to be... Yo.
Is that pi times both
Yes, okay. We do have a pi times both of those. And in fact, what I'm going to do here is I'm going to say,
Can you scoot it down a little bit?
oh yeah,
You're gonna make it just one interval.
yeah, I'm going to make it as one integral, but I can't make it as one integral until I square that. So it's going to be 0 to 3 of
1 plus 2 square roots of x
dx minus 1 dx. Yeah, I square, from this step to this step, I square that binomial. All right. Now, let's combine the ones. When I subtract here, we'll go play with the dodo birds. So I get from 0 to 3 of 2x to the 1/2 plus x dx. Are we good there?
Okay.
Would it still be 0 to? Okay, yeah.
Yeah, it's still going to be 0 to 3. The x values have not changed in here.
Yeah, I thought you took the derivative of that, but you didn't.
No, I haven't. All right, so what is the antiderivative of 2x to the 1/2?
3x to the 2
It's 2 over 3/2, right? Which would be 4/3. Is that what you said? Did I make a mistake? 2 over 3/2. Okay. All right. Plus, thank you. X squared over 2 from 0 to 3. Are we good here? All right. Now, from here, I'd plug in my 3. So it's going to be pi times 4/3. That's going to be the square root of 27. Because 3 cubed is 27, square root of 27, which would be 3 times the square root of 3.
So 4 on the square root of 3.
Yeah. Plus, and then 3 squared would be 9, so we get 9/2. Which would be pi times 4 square roots of 3 plus 9/2. That would be 8 square roots of 3 plus 9 times pi over 2. You wouldn't have to do that. That would be sufficient. I was just getting math happy up there and decided I needed to include everything.
I love math.